Okay, so last time we stopped here where we had defined an S3 class called infant that creates those growth charts that we see at the doctor's office. We're going to continue to talk about how to apply these for printing specific kinds of functions and storing the types of results that we want. Recall that odds ratios function from lecture 2. This was returned with a list of the objects that were invisibly stored within the object. And however, the results were always printed using a cat function, if you recall. Go back and take a look if you don't recall that. But we got the cat function to provide console output, but then the stored output was a little different than that. Let's say we wanted to call this odds ratio function many, many times, say 10,000 times within a simulation. We don't really want this cat function to be applied each time because it's going to have to print to the console and will waste resources during the simulation. So one possible thing we could do is to include an indicator argument. We're going to see this in just a moment. And this would just indicate whether or not that cat function gets applied within the function, the odds ratio function, or not. That's one possibility. Another approach is to define an S3 class for the function. So remember that an unassigned function calls will print the value returned, and that assigned function calls will not print anything. So rather than including the print statement within the function body like we did in the first attempt at defining this odds ratio function, we're going to assign a class name to that function and then write an associated print method. This really is the way functions are typically written if they're going to be distributed within R. So here's a odds ratio function, the original one. Recall, this is the cat function here, and this is the invisible stored object. So we could use an indicator. So here an indicator function we could call quietly. When quietly is false, it will automatically print the output to the console. But if we set quietly to true, then it will not print. This is one solution. Finally, we could take a look at defining a class associated with this. So this is going to notice all that we've done here is taken the basic calculations. In fact, everything from here up looks the same, with the exception of these checks on the function. So we have a function here, stop if not, which is useful for verifying arguments, making sure that the user has put in all those arguments that are required for it to operate correctly. And then here's some warning messages that might be useful. So if we have low cell counts would be the main one. Okay. Then right below it, but otherwise notice this is all the same. We do have a call to the class function here, which is going to define the class OR. Okay, so by the time you run a function or run a contingency table through this function odds ratio class, it will not only do these calculations, but also assign it that class OR and return that object that has class OR as a result. Then if we print that object, it's going to be printed in this manner. So here's our print function associated with the class OR. So if we just run this function, it's not going to print anything. If we just run odds ratio class, nothing will get printed. But if we print the object that's been run through odds ratio class, then we get it printed in this manner. So let's see the difference, okay? Here we have an X matrix, the one that we saw before. If we just run it through the original odds ratio function, this is from that cat function that was internally included in the function. We could save odds ratio to result. We still see the results of that cat function. So this is what we wouldn't want, say, within a simulation. And here, if we include that quietly indicator function, we have quietly equal false, so it's still going to print to the console. Finally, we have with the extra argument, the indicator function quietly equal true, and if we store it in result, notice nothing gets printed here. Okay, so this is a reasonable solution if you're going to use this within a simulation and don't want to see 10,000 odds ratio results such as these printed to the console. So this would work. But here's another one. Here we get odds ratio class. This would be the what would get printed if we just print result here. Okay, so now we're going to start on S4 classes. Recall at the beginning of this segment of notes, we talked about how S3 classes and methods are kind of old school. They're a little bit looser or more informal than the S4 methodologies and classes, and consequently, you can make some mistakes or have inconsistencies in your definitions associated with S3 classes and methods. So within the past few years, there has been a development and push for S4 class and methods being used within the programming in our programming environment. S4 classes and methods are created using functions in the methods package. So this is requiring use of a specific package. It's thankfully already loaded as soon as you install base R, so you all have access without installing that methods package right now. The structure of S4 classes is a little bit different. It's organized into slots, and each slot is named and requires a specific individual class. So this allows for a lot more care taken to the structure of the object that has a particular class or method associated with it. This is the main advantage of S4 classes. The class of the data in the slot must match the class corresponding to that slot. So, for example, it's not going to be possible to have numeric data in a slot that's designed for character data. And we actually saw the opposite of that before, where we had stored in the infant class, S3 class, we had stored character data in a numeric data location within an S3 class. So remember, it was the months age of the child, and we put 3 MON, 6 MON, and so forth. And it allows us to do it because it's not checking that the individual locations or elements of the method within the S3 class have particular structures. And this is the advantage, again, of S4, is that it has that general higher structure. So here are the basic functions with S4 classes. Set class just creates a new class. Set method creates a new method. Set generic creates a generic function. Remember, generic functions are things that operate specific to the class of the object. So things like print or plot are both generic functions. New generates a new object for a given class. Get class gives you the class definition. So before we used class, this is equivalent to class from S3. Get method gets you the method definition. Get slots gets the name and the class of each slot. At gets at or replace the contents of a slot. So this is much like the $ operator, or can kind of function like that. And then valid objects will test whether or not your object is valid for that S4 class definition or method. So here, I think jumping in and just seeing it in context of something we already understand, like the infant application, would be useful. So remember, to set a new S4 class, we use the set class function, and this requires a name for the class and a representation, so a list of the slots and their corresponding classes. So we can use new to generate a new object from the class also, and we're going to use both of these commands in the following code. So here we're going to first define our infant class, and now instead of being an S3 class like it was prior, now it's going to be S4. So notice we're going to call our class infant just like we did before, but our representation is going to contain those slots within our new S4 class infant. So we're going to have the ID, just as before, the sex, and the data. And that data, remember, has the height and the weight. And so notice how we've defined these. These have particular classes associated with them. This defines that ID must be numeric. Sex must be character. Data must be data frame. So it's not going to allow us to enter any of these values that are not according to these classes for each slot. If I try to say put in a string of numbers that have quotations around it, it'll reject that for ID because ID should be numeric instead. So we could run at this point, once we've run this command, we could run get class and get slots to see this structure internally and see that it's been applied. So now we're going to create a new object. So this is going to allow us to put in that data. So new infant, where data is going to be the data frame that contains the age and the weight and the height. Sex is going to be male and ID is going to be 1. Notice the slots don't have to be entered in any particular order, but you do have to use specific names assigned to these slots, ID, sex, and data. Okay, but here we've changed the order. Then we can get at the specific slots by using this at sign here. So X contains our object of S4 class infant, and to get at the data, I just do X at data. This makes a lot of sense, I think, in structure. So again, just to point out, the class of the slot must match what was defined up here. So take a look at this. Here's a new definition of a new object that's going to have S4 class infant. We've defined some data. We define the sex as 1 and the ID as quotation mark 001. Okay, do you think that this will work or do you think it will not? Take a moment. This should not work. There's 2 problems really. ID is in quotation marks, so this is a character string. Even though there are numeric values in there, it's a character string. Sex should be a character string, so we could put a 1, quotation marks around this 1, and it would be fine. It would fit the definition of character. But we actually expect to see something like male or female. Let's take a moment and look at the code. So here's the code S4 class. Notice here is our command line where we define our S4 infant class. If I just run that portion, we see that. So I can, again, as we just saw in the notes, I can get at the class using that command get class infant, and it shows me that this is a class infant. It also shows me information about the slots and what class they are. I can also use the get slots command, and it just shows me the information about the slots and what class they are. So then I can create, you know what, let me hold this just a moment. I don't have my old S3 class example run, so let me go ahead and run this data. I forgot to run that at the beginning of the session. So notice I have to have access to the age, the male height and weight, the female height and weight. So now I can create this new object X. Notice it shows over here in our list of objects within R, and it tells us this is a formal class infant. That's the, infant is the name of the class, and formal class describes it. It's X4. We could get information on it by expanding it there. I can get at the data, which would be that age and height and weight, or I could get at the sex this way. Okay, so remember, in Y we ill-defined both sex and ID, and if I try to run this, it's going to give us back an error, as it should, because these are not consistent with how we define those slot classes within the infant class object. Okay, so we'll stop there and go on to more information about S4 classes in just a moment.